Hi guys, it's fairly difficult to show you my calculator over here, but it's got a whole bunch of things. I have a button here says compound, okay? And from the compound it says set, and it says make the payment at the end of a period. I'll be teaching this in the next chapter. Then the next button is N. How many I got, how many periods. And I say 1 period, okay? The next one is asking me interest rate, and I say interest rate of 12%. The next one is asking me, well, what's the present value? And I say the present value is 1, okay? Just want to see what's happening. Next one, what's the payment? Is there a payment in between? There is no payment in between. Payment is 0. What's the future value? And I got two things here. One is called number of compounding, how many times you compound per year. So I'll put the compounding number to 1, and then I say calculate the future value, solve, and it says 12. Now all I'm going to do, compound 2 times, let me see, and recalculate, solve, 1236. Now, if you say 4 times, I just change 4 times and then say recalculate. I use the button solve. For 4 times becomes 1255. Is this what we got last time? And if you calculate, let's say 12 times, I go back 12 times, recalculate, okay. Enter, recalculate, solve. It says 1268. Okay? And it's that simple. 1268. Now, if I say, well, do this for, let's say, 5 periods. And I just type in n equal to 5. Enter 5. And then recalculate the future value. And it says 181, okay? So it just gives you a very quick, very easy, very straightforward calculation. You have about 7 or 8 numbers. You just got to plug in whatever the number is and say calculate. When you change the number, say recalculate. And it can say calculate the present value, calculate the future value. So for both compounding and for discounting, I'm using the same thing. So now I should usually, when you have more often compounding, it's very easy to forget your compounding twice. So it's always a good idea to reset it back to compounding 1 time. All right, let's get back to what we, or at least I, was doing, which is section. So we did the timeline, we did the compounding, now we're on to discounting. Section 3. Discounting is the opposite, the exact opposite. And it's a simple formula. It's the same formula. Future value, remember, equals 1 plus I to the power of n. This is future value of n times present value. Now we move this forward to solve for present value. So equal present value equals future value n divided 1 plus I to the power n. And that's it. So now I just rewrite it nicely. Present value equals 1 over 1 plus I to the power of n times future value. All right, this thing becomes the conversion factor. Before the conversion factor was called, what was it called? Future value. What was it called? I wrote it on the board. You got to take a look at the notes. How did we call it? Future value? Interest factor. So this becomes present value interest factor. Back in the old days, we just call it a discount factor. All right. So discount. Let's see what else I got. Present value interest factor. That's page 154. Why do you guys keep talking all the time? It's like, they just keep talking. Can't stop, right? That's page 154. This thing here, I, the interest rate, I, is actually called a discount rate. Discount rate. So, discount rate is the interest rate used to calculate present value or used to discount. Okay? The whole process is called discounting, and this interest rate is called the discount rate. The other interest rate will be called the compound rate or the compound interest rate. This could be discount rate or it could be the discount interest rate. Both of them. The other will be compound rate, compound interest rate. Alright, enough fun, okay? Because I'm going to mark absence. Next, that's again page 154, page 154. Chart. Well, suppose you have $1,000 somewhere in the future. Well, why they have it like that? That's okay. So, they show you basically that if this is the asymptotic line, when you discount 1 year out, that's the present value. 2 years out, that's the present value. 3 years out, that's the present value. 5 years out, that's the present value. And actually this goes down. This keeps going down. Okay? And if the interest rate is higher, the curve will be steeper and deeper. All right? So that's what it looks like. And they have some problems over here. I'm curious, this problem. Do you guys have a textbook? Well, you should, right? So, what I'll do is I'll try this problem here on 155 and see, somebody write a time, clock the time, see how quick I'm going to do it. So, it simply says, the present value of 500,000 to be received in 10 years. So I say compound, I say n is how many years? Change the years to 10. The interest rate says 6, I put in 6. The present value we don't know, the payment is 0. The future value is 500,000. Okay, so I put in the 5000. I can look. I gotta enter this one and this one. So I just say, well, what's the present value? Solve. I got a blue button for solve. When I click, it says 279. 279 in the textbook. And then, what does it say? 279 for the present value. Well, what is it? What's the number? 279197. All right, well, look at the textbook here. It says step 3, at the bottom of step 3, 279197. That's it. It takes about 30 seconds. 279197. Very quick, very easy. You just plug in the numbers. All right, let's do again quickly. Let's do again. Step number 5. Again, we're going to be doing 3 hours of exercises. What is the present value of 100,000? So, where's the future value? I say 100,000. I need to enter the number for how many years? 25. N equal to 25. And interest rate is, what is it? 5. So I plug in 5. And then say present value, recalculate. I get 29,530. Oh, yes, 29,530. Magic, quick. Again, it takes about 15 seconds. All right, very easy. You just change the numbers, whatever the numbers are. So, I just solved for you this. We're going to do the same in the lab next time. Well, next time is going to be quiz. Today we're going to try and finish 5 minutes early so that you guys decide when is the midterm, okay? And next time I'll be trying to solve these things for you on the board with Excel, and you're going to use your calculator and do the same thing. Guys, later, okay? The last 5 minutes. Now, so I solved these problems. That's on page 155. Let's see. 2 additional types of discounting. All right, 2 additional types of discounting. So, in discounting, problem number 1, which I just showed you, the most standard, the most common problem is simply calculate the present value. And it says, well, what is the present value? That's the simplest, that's the easiest problem. But you may have more difficult problem, which is, well, the present value is $1,000, okay, and I want the future value to be $10,000, okay, and the interest is like 15%, if you can get 15%, okay. So now the question number 2 becomes, what is it? How many periods of time it requires to increase your money 10 times, okay? The same question will be to turn $100,000 into $1 million, okay? Or usually the question, a little simpler question is how many times it is to, let's say, double your money. So, to double my money, I write present value 1, future value 2, interest rate is, I'm just picking a number 3%, and N, and let's take, or try for me to solve this problem, see how I'm going to do. So, present value, I say 1, enter. Payment is 0. Future value is 2, enter. Interest rate, I need to find the interest rate. Interest rate is 3, enter. And then I go back to N, and when I set the end, I just say solve. Oh, it says math error. All right. Error. What is wrong with my calculator? Short answer is nothing's wrong with my calculator. What is wrong is me putting in. This is cash inflow and this present value, future value. Let's see. Sometimes we need to have a negative one. So you need to have minus 1. Let's see what happens with minus 1. If minus 1 will actually work. Back here, AC. I need to see where it is. Oh, I got to reset. Compound. N equal to, well, that's interest rate 3, present value 1, payment. So future value, let's try minus 2 and see what happens. Let's see if N will recalculate or give me error. Oh, it says N, 23.45. 23.45. In other words, it's going to take about 23 and a half years at 3% to double your money. All right, now let's try 4% and see what happens. I just say 4, enter, recalculate, and will be 17.67. 17.67. All right, and what it is, 10%. If it's 10%, I just plug in interest. 10, enter, and recalculate 7.2. All right, 7.2 years. Again, once you set up the calculator, once you understand, it takes about, what, 10 seconds? 15 seconds. Okay, so here's the trick. When you have present value and future value, usually one of them has to be an inflow, the other one has to be an outflow. So notice the following trick. This, the way I wrote it, is no good. Guys, the calculators, pay attention. If you write present value minus 1, the future value will be plus 2. Or you can write present value plus 1, future value minus 2. Okay? That's how the calculators work. That's usually confusing for students because here minus 1 means I invest today $1, I will get, so I invest, pay out, I will get back 2. Or here, I receive $1, after 17 years I will have to pay back $2. Okay? So this is pay, invest, and then receive. This is borrow, and then pay back. That's the thinking and the logic about it. All right, that was a nice trick. Oh, okay, well, you have this same thing, which I've been kind of like explaining. They have it here on page 156. And on page 156 at the bottom, it shows you the calculator. And in the calculator, you put in the interest, whatever, 10%. You put in present value, whatever it is. You put in 20,000 for the future value, and it does some sort of a calculation. It's asking you, calculate for N. And I'm doing exactly the same thing. So that's solving for the number of periods. And the other one is, and I just did a little bit of it. It's called section number 2. Next section is, it's a very simple, very easy rule. It's called Rule of 72. Rule of 72. If interest rate is 1%, it takes 72 years to double your money. Rule of 72 tells you how many years it takes to double your money. If interest rate is 1, you divide 72 by 1 is 72 years. If interest rate is 2%, 72 divided by 2 is 36 years. If it's 3, divide by 3. Anyone with a calculator? 72 by 3, how many years? Huh? How much? 24. 24. Okay. Now, notice the following. 24 is by the rule. The rule is approximate. Close, but very good. The true number is 2345. Now, apply the rule for 4%. But 4%, what's the rule saying? 18? Alright, I'll take 18, which is kind of like 1767. Okay? What about 10%? For these guys over here. 72 divided by 10% is 7.2. 7.2. And amazingly, I got 7.2. Now, let me just, for fun, if somebody's got a financial calculator, let me calculate this thing for 2%. I can do, for 2% interest rate, I say 2, enter, recalculate n, says 3500. Okay, 3500. Okay, and if it's 1%, the exact calculation is 6966. So, you can see the calculation is pretty good and very close between, let's say, 8 and 10%, or 5 or 10. Now, in the real world, this is a very good calculation. You know, again, whether it's 70 or 72 years, it's pretty much the same thing. Whether it's 35 or 36, it's pretty much the same thing. Okay, the error is relatively small. 23 and a half and 24 is pretty much the same thing. It's just a nice rounding, but it's a quick and easy way, for example, to answer the question, how long is it going to take to increase my money 8 times? Okay, 8 times at, let's say, 7%. Well, at 7%, you double your money in 10 years, according to the rule, okay? So, you make it 4 times in 20 years. You make it 8 times in 30 years. It's quick and easy. And when I do the calculation, you should get a number of roughly about 30 years. And I can do the calculation very easy. All right, so that's the 1. And then problem number 3. Problem number 3 is solve for the interest rate. Okay, solve for the interest rate. So what will be solved for the interest rate is the following. You borrow money, let's say $1,000. Your borrow becomes plus, and they say you gotta pay, let's say after 3 years, you gotta pay $1,500. Okay, so what's the interest rate in that particular case? Okay, well, if somebody has a calculator, you can try. So I say present value plus 1,000, enter. Future value minus 1,500, enter. Okay, and then I say, what is it? N equal to 3 years, enter. Calculate the interest rate, 14%, 14.47, interest 14%. Right. Okay. Now you can maybe do the opposite and say, okay, take 1,000, use 1447, and after 3 years, what do you get? Okay. So here, with the calculator, it's amazingly simple calculation. Again, it takes 10, 20 seconds once you learn how to do it. Let's see what else we have, because you worry about the quiz and the midterm, right? So, let's see what they have here. Okay, well, they have, let's try and do this. Page 159, there's like an example. See if I can check myself. The example, step number 3. What are the numbers? It costs 20,000. 20,000 in so many, but you only have 11,600. So, it says future value 20,000. Let me try and say present value 11,167. I'm looking page 159. There's an example. Present value 11,167. 11,167. Enter. Future value 20,000. Future value. Oh, it's got to be minus 20,000. Okay. And what do I have? What else do I have? How many years? 10 years. N equal to 10. N equal to 10. Enter. And our interest rate, so 6,0,0,0. 6 with like 3 zeros, okay? So, the solution is 6%. What do they say in the textbook? When it's solved? When it's solved, it's 6%. Alright, look guys, they gave you the answer in step number 3. Over here, take a look. There is this here. You punch in the numbers, and it says answer, 6%. Before that, on step 3, you'll again have 6%, okay? So, these are some examples for you to watch either the lecture, or you just go through these checkpoint 1, 2, 3, 4, 5, and 6. You should be able to recalculate these on your own calculator or on Excel. And again, we'll be doing this next time a lot. Okay? Okay, well, here's another one. Step number 5. Step number 5. Take a look. At what rate will 50,000 grow to 1,000,000 in 30 years? So, present value, 50,000. Enter. Future value, minus 1,000,000. Again, you can do the opposite, minus 1,000,000. Enter. N equal 30 years. And interest is question mark. Solve. 10.50. 10.50. Let's see. Yeah. Works. Alright, I'm like the kids. Okay, it works. 10.501. Well, that's the answer. Again, these examples, notice, take about 10-20 seconds if you're good. And you're expected to get good. And if you solve 20, 50, or 100 problems, you will get good, okay? It's not difficult. It's not complicated. And we will be doing the same thing, hopefully, next week. I'll be doing the same problems on Excel, on the board with the projector, and you'll be doing it with your calculators. You're going to be double checking. Okay. Now, ideally, guys, you'll bring your own laptop, and you're 2 guys, meaning one will do the laptop, and the other one the calculator, and you're going to double check and match the answers. Let's see what else I got. Section number 4. Okay. I covered a little bit. Alright, section number 4, I got 10 minutes. I should have no trouble if you guys pay attention back there. Yeah, the two of you. All right. So, section number 4. This is complete. Now we're doing comparing interest rates. All right. I already gave you the examples. Now what we're going to do, that's page 160. The one interest rate is called APR. APR. Meaning, what does it mean? What does it mean? You got page 160? Annual percentage rate. And the other one is called PAR, which is? So it's got to be effective. Effective, what is next? Annual rate. Alright, so what does it mean? It means what I was already explaining before with my calculation. It means that if the annual percentage rate is 12%, the effective rate, if it's compounded twice, will be 1236. So now let's try and explain a little bit. The effective annual rate is the rate which takes $1 and tells you how much it grows in exactly 1 year. So this is the true, genuine, actual interest rate. We call it the effective. What you really actually pay. So it means the following. If you borrow 1,000 and you're going to pay 1,236 dollars. Oh, no, there's no percent. This is the same as my mistake. 1236. So I gotta say 1,000. 1236. I gotta say 1,000 times 1, 2, 3, 6. Okay, that's the calculation. Okay, 1, 2, 3. So you pay 1, 2, 3, 6. That's after the 1,000. Is that correct? I think so, right? So that's 1236. All right. Now, what is the annual percentage rate? The annual percentage rate is the interest rate for the period multiplied by the period. So, if the monthly equal 1%, you multiply by 12 to get 12% APR. Okay? They say interest rate only 2%. Interest rate only 2%. So, interest rate only 2% will mean multiply by monthly 2% by 12 is 24% APR. Okay? And if they say quarterly is equal to 5%, okay? If it's quarterly, we multiply by 4 equals to 20% APR. Okay? Well, APR sometimes can significantly reduce, lower or underestimate the true, genuine interest rate that you pay. Well, let's take a look for my calculator and see if I can figure out what 24% APR would actually equal to if it's compounded monthly. Let me try and see if I'll do that. I say compound period is equal to 1. Enter. Interest rate is equal to, it's going to be 24. Enter. Present value is, what is it? The present value is 1. Enter. Payment is 0. Future value is, we're going to calculate. And now it's 12 times. Calculate the future value. And say solve. 2682, it tells me. 2682. Let's see if somebody. 2682. That's what my calculator says. Okay? Here it's 5 times 4. So I'll just type in interest rate is 20. Okay, interest rate is 20. Enter. And I say that it's 4 times per year. 4 times per year. Recalculate, solve. And it tells 2155. 2155. Alright, just a simple example. Let's see what they say. Picture the problem, so many, whatever. Calculate. Now, they give you can do the same calculations daily. Okay, you can do the same calculations daily. What do they have here? EAR, what do they have? An annual rate of 21.7. What is the EAR? What's the solution? Alright, so I say, now, page 161. Example, it says 21.7. Let's say, okay, interest rate is 21.7. Enter. How many periods? Okay, it's for the same period. We'll use the equation to solve. Oh, they compound 365 times. Okay, I can try and do that and see what I get. 365. Enter. Show me the future value. 24.22. What do they get? 24.22. Yes, 24.22. All right, so let's write out the example. Daily. So APR equal to 21.7. 7%. Compounded daily equals to EAR, and I'm giving it a precise number, is 24.22639. 22639. And in the textbook they say 24 point. What is it? 2264. 2264. Again, very quick, very easy calculation as long as you know how to set up the calculator. Okay? Very quick, very easy. Oh, next one. Step number 5. Okay, I'll try for you step number 5. It says interest rate 13%. So I go back to interest rate, type in 13 and enter. And then we have Compounded monthly. So I say 12 times, enter, and then calculate the future value. It tells me 13.8%. 13.8%. That's it. Very quick, very simple. Let's see if we got something else so we can finish now. There's some other stuff. Okay, periodic rate. Okay, well, the last concept here, okay, I will do this part over here if I can do, is simply called the periodic rate. Periodic rate's got to be the quoted annual rate. It's the same as APR divided by periods, number of periods. Now, example. APR equal to 12%. The monthly periodic rate, monthly is equal to 1%. The interest rate, quarterly periodic rate is equal to 3%. Semi-annual is equal to 6%. And annual is equal to 12. All right. Here, you see, this is 2%. That's the periodic rate. This is the periodic rate. And this is the periodic rate. So, you get the periodic rate, multiply the number of periods. Okay? This is the periodic rate, multiply the number of periods, and you get 20. Okay? That's the APR. And that's, it just has a name. And that finishes all. Okay?